Neither of our prior segments in this topic included an external research component. We'll make up for that now and get fully up to speed on a central C concept, the operator precedence table. The issue of operator precedence comes up with a vengeance in bitwise operators. You may have noted some rather intricate parentheses, as on line 22, for instance, of our example code. It'd be easy to extend this lecture to cover the precedence of the bitwise operators vis-a-vis the arithmetic operators, etc. But we've reached a point where you should do external research on this instead. Every C programmer knows where to get their hands on a C operator precedence table, and most of them have the majority of the operator precedences memorized. Knowing the precedence table by heart is now official vocabulary in this class, and is testable via questions like name an operator that has precedence higher than x but lower than y, or parenthesize this expression redundantly to show the order in which operations would occur. And this includes the rules for association of same precedence operators, which is usually left to right, but which in two precedence groups is right to left. Unary operators, like address of or plus, plus increment, etc., and also assignment operators. We've covered them both in prior lectures. While we're at it, this is an excellent time for you to do a full review of the entire C operators set. You should now know every operator in the precedence table, either because we've covered them or because they're obvious extensions on ones we've covered, like the zoo of different shorthand assignment operators, plus equals, minus equals, etc. Go and look up a good web or text reference on the C precedence table and review every operator in it to be sure you know what they do. Research those you're not certain of, and be ready to field the in-lecture questions below from memory without needing to consult the precedence table. And to help speed you on your way and make a point about how critical this stuff is, I'll tell you that in the standard K&R text, you'll find the operator precedence table on page 53. And get this, in the old version of that text, which was replaced in the late 1980s when ANSI C came out, and which I have not personally used in nearly a quarter of a century, the precedence table is on page 49. Now, I don't love K&R so much that I memorize all its page numbers. Those are the only ones I know. And obviously I consulted page 49 so many times in the 1980s that I still remember it today. Copies of those pages from K&R may be found pinned up on cubicle walls in dev shops all over the world. At one point there was even a geek t-shirt you could get that had the C precedence table on it printed upside down so that you could look down and consult your own shirt when you needed to check an operator precedence. So here's question 5. With your possibly lengthy research all done now, how would this expression in the transcript be evaluated? Add parentheses to show the order of evaluation implied by the precedence rules, which you have at this point memorized. Coming back from a pause, the parenthesizing of the expression thus would be that. So let's review that. All bitwise operators have lower precedence than all arithmetic operators. So the +1 would be done first. Shifts are just underneath the arithmetic operators, perhaps because they have some arithmetic meaning. And down below them are ampersand and pipe, bitwise and bitwise or. And the bitwise and has higher precedence than the bitwise or, just like double ampersand has higher precedence than double pipe. And importantly, the entire right-hand side of the expression is grouped because the assignment operator, and it is an operator, has almost the lowest precedence in the entire table, and is therefore done last. So the next question has to do with the parentheses operator. Now, this is not the standard grouping parentheses. Those don't count as operators. If that's a surprise, and you thought the parentheses in the precedence table had to do with grouping, then go back and complete your research on the 4 operators in the top precedence group of the precedence table. Parentheses, brackets, arrow, dot. They're among the most important, but they are also among the oddest ones to view as operators. So, assuming you've had that research, then question 6. How many operators are there in this expression, as seen in the transcript, and in what order are they done? Coming back from a pause, there are 3 operators here. The first to be done is the dereference operator. The next is the bracket 5 operation, since array indexing is an operation, along with arrow, in the topmost precedence group. And since association is left to right in that group. And then finally, there's the function call operator. Calling a function is an operation. We'll shortly see cases where we do function calls on things other than standard functions, in fact. Reaching question 7 then now. Despite having programmed in C for 30 years, I still had a bug when writing line 22 of our example code, which I originally wrote without the parentheses here as this instead. When bit 1 and bit 2 had values 6 and 8, respectively, I found that this set the bit at position bit 1, but it didn't clear the bit at position bit 2. And that baffled me for a minute or two before I saw that I needed parentheses around that OR operation, and adding those back, that was my bug fix. So, explain exactly the order of operations that would occur in my buggy version of the expression, and why the result would be as I described, setting bit 1 but not clearing bit 2. And specifically, by the way, what is the result of the AND operation in the buggy version? Coming back from pause there. The order of operations would create the 2 masks first, since shifts have higher precedence, as does tilde. The expression would then bit AND the masks, because AND has higher precedence than OR. And only the 1 bit at position bit 1 would survive that bit AND, since that's the only position where both masks would have a 1 bit. The resultant mask, with a single 1 bit, would be bit OR'd then with I, setting the bit at position bit 1, but not clearing the bit at position bit 2. Here's another precedence-related question for you. Assuming I, j, and k have the values 1, 2, and 3 respectively, then the following assignment assigns 2 into val. Why? Coming back from a pause there, the reason is that addition has higher precedence than question mark colon, the conditional operator. And so what you'd get is that I plus j is 3, which is not less than k. So the value of the conditional expression is that of j, which is 2. And then a final one. The if statement I'll show here is true, but it prints 1.0. Why? Coming back from the pause. Because assignment has lower precedence than less than. And so what you're getting really is that. So the comparison is done first, returning a true value of 1, since the square root of 9.0 is less than 4.0. And the result of that comparison is then assigned into j as 1.0, and becomes the if test, thus true. But j ends up containing 1.0, not 3.0, as might have been expected. At this point, you might be inclined to throw in the towel and parenthesize everything just to be sure. Don't do this. First, it's a violation of the course style sheet. Second, the code complexity metric penalizes you for each pair of parentheses. And third, and most importantly, over-parenthesizing your code is like adding a comment saying, I never really could figure out precedence. The very reason for the precedence table is to avoid parentheses. If you're going to parenthesize everything anyway, there's no need for precedence at all. Invest in knowing the precedence table, and use your investment to simplify your code. If you want heavily parenthesized code, then write in Lisp.